Now, on this next session, I would like to show you a little bit of a calculation, and the two basic calculations we can do on the Smith chart. We already discussed them, but I would like to give you some numbers. So here's a load that we can just basically point on the Smith chart, and the first basic calculation is to read that load. And here I'm using the complete Smith chart, the one you can actually print and is available online as well as on our class website. So the minute you plot a point on the Smith chart, first, it's always a good idea to find the real part. In this case, it actually passes through the circle that reads 1 right here. And so that means that the real part is 1. And then you basically look at the imaginary circle, and you look at the number listed right here. This actually also reads 1. And that means that this load right here is the 1 plus j load. So you can do that for any single load somebody plots for you, whether it's here, whether it's here, whether it's here, whether it's here. Now, in the old days, when the primary reason for using the Smith chart was to actually do computation, people spent a lot of time trying to read these numbers really accurately, and they were saying, well, what if my load runs right there? Don't have a huge inaccuracy? How do I read exactly this number? Is this number 0.63 or 0.62 or 0.625? The reality is, in today's world, it doesn't matter. You can actually make that calculation very simple with a numerical calculator. But what it does matter is that if somebody basically tells you, here's the load of 1 plus j, that you can mentally place that load on the Smith chart. You can immediately bring the picture you see here in your mind. That's the important piece. Now, by putting a load on the Smith chart, we can also find out, as I mentioned before, exactly the reflection coefficient. So the reflection coefficient here has a magnitude of 0.45 and an angle of 63 degrees. How do we find the magnitude of 0.45? Well, as I mentioned before, we measure this distance. Let's say it was 8 centimeters. We measure this distance, and the division of that basically gives 0.45. How did I find the angle 63? Well, I start from here. Remember that this is my real axis, and this is the imaginary axis. So I start from here, and I simply measure this angle. You can either measure the angle with your own instrument, or you can basically go to the scale of the Smith chart. There is a scale of the Smith chart right here that actually measures angles. And right here is the angle of 63. This number here is actually 60 degrees. There are actually various scales around the Smith chart, and I would invite you to basically utilize them and study them. But this is definitely one that is very, very widely utilized. So that's our first basic calculation. Now let's go for another basic calculation. So let's say that somebody says, plot me this reflection coefficient, 0.62 with an angle of negative 123. So again, I will basically go ahead and first of all find my angle. The angle is negative 123. So I have to go ahead and measure all the way down to 123 degrees. Or I can use the scale of angles right here. So this number here is negative 123. And then simply take 62% of the distance between the edge of the Smith chart and the center. So when I take 62% of that distance, I will end up with this point there. And then it's simply good enough to read the scales for the real part. So if you look here at the real part, it actually passes through the 0.3 circle. So that means that this load will have a real part of 0.3. And then it's OK to simply look at the imaginary circle. Now the circle is on the bottom side, so essentially that means that it will be negative. And if you just read the number that you will have on the Smith chart, this will end up being 0.5. So these are the two basic calculations. One we did before, where somebody gave you the load, you plotted the load, and you measured the reflection coefficient. Or somebody gives you the reflection coefficient and asks you what load is causing that, which is the one we just did right now. And it takes a little bit of practice. In fact, I would advise you to do at least 5 of them per day for at least a full week before you can read these numbers correctly and you don't make mistakes. It takes a little bit of practice, but once you do it once in your life, you remember it until you're really, really old. It's a little bit like learning how to bicycle.